Okay, we're going to try this out. This is my first attempt at recording how to do something using video capture on my computer. It's not going to be very exciting because we're going to be doing Newton's law of gravitation. Basically the notes that we're doing, except that instead of teaching you as a class, I am teaching an empty classroom into a screen. What you're looking at here is what we have exactly on the screen at any given time in the classroom. Here are the notes right here. So we did do this in class already. This is just a review. So these are the notes for Newton's law of gravitation. Basically what that says notes. Basically what this is what we've been talking about all year. Anything that has mass has gravity, and there is a relationship between those two. This formula talks about that relationship. The first thing we have to do is come up with the formula. There actually is a mathematical formula, and that's what we're going to focus on today. And that is what that force is. Remember, gravity is a force. So this is the force of gravity. And how do you determine that? Well, it turns out that in order to solve this equation, you can't just say mass and gravity of two different objects pulling on each other. There is something, there has to be a number that makes it to make sense. And this is this capital G. This capital G stands for gravitational constant. Okay. Now that gravitational constant will always be the same number. And that number is, write this in red so you guys can see this, 6.673 times 10 to the negative 11 power. This is in Newton meters squared divided by kilograms squared. Now, all of these units are important, and I can't stress enough so you can figure out what you're solving for in the end, and what cancels out and what doesn't. All of those things have to be taken into account. By the way, this little FG, that stands for the force, because that's what we're trying to solve for, of gravity. So this is gravity that we're trying to figure out. This capital G does not stand for gravity. It stands for the gravitational constant, which is just this number right here. And it will always be that number. It never changes. All right, now what are we going to try to figure out? Well, we're going to be trying to figure out anything that has gravity has mass, right? So two objects that have mass will be pulling on each other at what force? Well, we look at these two objects. We're going to call those mass 1 and multiply it by the second object that has mass. Okay, so these two objects right here are considered to be mass. And mass in this case is always going to be measured with the units kilograms. All right. So we're going to take those two masses and multiply it together. I'm going to put those in parentheses because we're going to multiply everything in this parentheses by this gravitational constant. We also got to take into account that the further away an object is, the further away two objects are from each other, the less gravitational influence they have on each other. In other words, they're like a magnet. The further you get away from each other, the less pull, the less force there is between them. So we have to take that into account. Typically, the bodies in space are orbiting each other. So if they're orbiting each other, they're going around in circles. So we're going to be looking at how far from the radius those are from each other, from the circles that they make. And we're going to take that number and we're going to square it. So that's our formula. Let's see, we'll go ahead and just label this as being the radius. Okay. All right, the next thing that you need to know is what are the masses of the two objects? In this case, well, I'm going to use an example. One of our students in the class that I did this example for, his weight was about 150 pounds. That comes to, if we were to convert that into mass, that comes to about 72.6 kilograms. Okay. And I wanted to compare that to, I know what it was, that the weight that holds my door open to my office in my classroom, and that was 22 kilograms. And we wanted to know what was the pull between those two. What was the amount of gravitational pull between that student and that mass? So to do this, we use this formula. The force of gravity equals gravitational constant times mass 1, 72.6 kilograms, times 22 kilograms. And then, should get that a little bit bigger. Then we measure how far that those two objects were apart, the student from the mass that we were looking at. And we found out that its radius or the distance between the two was about 6.5 meters. All right, so that's the radius. So we're going to say 6.5 meters. And then, now a lot of people make the mistake and they'll write squared because it's radius squared right there, you see. We can't do that because we have 6.5 and we have meters. That's two different things, and we're squaring both. So we have to put that in parentheses, 6.5 squared. All right, moving along, let's take this to the next step. I'm going to take my calculator and I'm going to say, well, 72.6 times 22 equals 1,597.2. So I'm going to write this whole formula again. Force of gravity equals gravitational constant. This time I'm going to write that gravitational constant in for kicks and giggles. 6.673 times 10 to the negative 11. Remember, it's important to write those units. Newton meters squared over kilograms squared. All right, now, in parentheses, we multiply it across the top. 72 times 22 is going to be 1,597.2. That's kilograms times kilograms, so that comes out to be kilograms. When you multiply two units by themselves, it's going to be kilograms squared. All right. Now we need to do 6.5 meters squared. So I'm going to take in 6.5, and then I'm going to hit on this calculator. There should be a little squared symbol. There it is right there, x squared. I'm going to hit that just to square that. So 6.5 times 6.5, or 6.5 squared, is 42.25, and that's meters, but we squared it, so that would be meters squared. Now this is important because now we're going to multiply the gravitational constant times this number that we just came up with. Notice that kilograms squared here and kilograms squared here, this is the numerator, this is the denominator. When we're multiplying the two, they cancel each other out. Same thing here, meter squared and meter squared here, they cancel each other out. That leaves us with these numbers. Really, all I got left here is the newtons. And that's what force is measured in. Remember, force is measured in newtons. So now it's time to do some more math. Let's go ahead and finish what's in the parentheses because I know my math teacher always said, finish what's in the parentheses first and then multiply outside of the parentheses. 1597.2 2 divided by 42.25. Now, all the units in there have canceled out. So what I come to is an answer that looks like this. 37.8. And notice I've got 4 numbers here as the least number over here. I have to have, if I've got 4 numbers as the least amount of numbers I have to match it with 4 numbers. So I'm going to have to say 37.80. There are no more units there, so I don't need to write units. So we're just going to leave it like that. All right, so now I still got to multiply it by this gravitational constant. So 6.673 times 10 to the negative 11. And we're left with newtons. So we still need to write the unit. Now, really, it's just we got to multiply this number times this number. But this is what's going to throw a lot of people off, because 10 to the negative 11, that is an exponent. That's a power of 10 to the negative 11 power. So let me take a quick moment. I'm going to step off to the side, and I'm going to talk about what these exponents are and how do we use them on a calculator. So an exponent, if we see something like, and this is completely unrelated to the problem that we're doing, 2.75 times 10 to the, 8th, okay? What that means is that this number is multiplied times 10, and that's 10 to the 8th power. That would be like saying 2.75 times 10 times 10 times 10 times 10 times 10 times 10 times 10. That's 8 times. I think I said 10 8 times there, right? Well, in order to do that, times 10 times 10, 8 times, that would be like saying 10, 2, 3, 4, 5, 6, 7, 8. Okay, this number times this number. Or, to make life just easier, really what you're doing whenever you're multiplying by 10 or powers of 10, you're just moving a decimal point over. How many times am I going to move the decimal point over? Well, 8 times. So this would be 2.75 times 10 to the 8th power. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to put the decimal point here. What do I do with all these other blank spots? Well, you guys probably know by now. You always fill those up with zeros. So 2.75 times 10 to the 8th is basically like writing 275 0, 0, 0, 0, 0, 0. Put our little commas in there to separate our hundreds and thousands. So that would be 275 million. So this number and this number, the exact same thing. Conversely, if I have 2.75 and I multiply it times something that says 10 to the negative 8, well, it's the same thing, except that the negative 8 means it really should be written as 2.75 divided by 10 to the 8th, which means we're dividing this time, not multiplying. Same thing, 10 with that many zeros behind it, which really makes life simple for us, because if we say 2.75 and we're dividing by 10 to the 8th, that means we're going to move the decimal point. Oh, I wrote that in a bad place. 2.75. I'm going to move the decimal point. Well, I'm dividing. So I'm going to move the decimal point to the other side to make a really small number. 1, 2, 3, 4, 5, 6, 7, 8. Put a decimal point there. And of course, we have to fill in all those empty spots with zeros. Okay, so 2.75 is 0.000. Now we've got 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 zeros. Not 8 zeros, because we have to move that 8th decimal spot over the 2. 275. Those are essentially the same thing. Now, if we were going to have something like this, one last thing, let's say 0.000296. All right. How would I write that as an exponent? Well, I always want to move the decimal point between the first and second numbers. I want that decimal point to be right here. So I have to move it over 1, 2, 3, 4 times to do that. So that would be 2.96. Since it was a really small number, I'm going to say times 10. How many times did I move it over? 1, 2, 3, 4 times. So that would be a negative 4. Or if it was 294 million, this time I would write this as a 2.94. How many times I move the decimal point over? 1, 2, 3, 4, 5, 6. Remember, it's got to be between the first and second number. 7, 8. So 2.94 times 10 to the 8th power. Now, your calculators, depending on your calculators, how would you type 2.94 to the 10 to the 8th power? Well, you would write 2.94. And you should have one of two things. In this calculator, it says EXP. On this calculator, it has EE. Basically, what you're going to do is you're going to hit the EXP or the EE button. And there's two different ways, depending on the quality of your calculator. Some calculators are even different from this, but it either says EXP or EE. And then you type in how many it is. In this case, 8. So 2.4, what this is saying is 2.94 times 10 to the 8th power. If I had it equals, it actually figures it out. In this calculator, 2.94, and I'm going to write to the 8th power and hit equals, and you notice they come up with the same thing. Hopefully they have the same amount of zeros. Many times you're going to get a calculator 2.94, and if it's a really, really big number, let's say like 25, and we're going to be dealing with really big numbers and really, really small numbers in this class. You know, as I hit equal until the cows come home, it's nothing changing here. That's because the calculator doesn't have enough zeros to put it in there. So the calculator automatically does the exponents for you. What if it's a negative? What if it's 2.57, like this right here, times 10 to the negative 8? Well, you would type in 2.57, hit the EE button, and then you type in 8, but you have to hit this plus negative symbol to make sure it's a negative number. So 2.57 times 10 to the negative 8, and it's going to give you that. Kind of the same thing on this one, 2.75. I think I've been saying 2.57. 2.75, hit the exponent, and 8, and then hit the negative, and it's going to give you that really, really, really small number. All right. Okay, so let's get back to what we were talking about a minute ago, which was this piece of paper right here. We had almost had it solved. The force between that student and the weight. We have the gravitational constant, and we've done all the math inside the parentheses and came out with 37.80. I mean, if you really want to do this longhand, you can, but at this point, when we're dealing with such large numbers, I think even NASA scientists are using calculators at this point. All right, so we got to put in the gravitational constant. That means we have to use the exponent. So we're going to use the student calculator so you guys know how to use it. 6.673, and I need to hit the exponent. And I'm going to say 11, but that's a negative 11. So I'm going to hit the little negative there. And I'm going to multiply that by 37.8. And that's going to give me this answer of force of gravity, how many zeros? 1, 2, 3, 4, 5, 6, 7, 8. So that answer equals force of gravity equals 0.1, 2, 3, 4, 5, 6, 7, 8. And then there's a 2 after that. And do take into account, I think my calculator rounded off, but we have at least 3 significant figures right here. So it's actually going to be 2.200. And then that's going to be in newtons. Now that looks a little weird to me. That's a lot of zeros. It's hard for me to comprehend that. So I'm going to write this again in scientific notation. Force of gravity equals, and how many times am I going to move my decimal point over? Well, I'm going to do it 1, 2, 3, 4, 5, 6, 7, 8, 9 times, which leaves me with the answer of 2.00 times 10, and this is going small, so -9. That's not a very big force between those two objects, hence why the force between those two objects and the Earth are much, much, much larger, and that's why that student and the weight don't pull toward each other in the middle of class. However, when we start looking at things like humans and the Earth, or possibly moons and their planets, or maybe even planets and their stars, those numbers are going to get significantly larger. So instead of getting a -10 to the -9, you might be seeing something like 2.00 times 10 to the 24th power. So that's the thing that we'll be looking at. I hope this was helpful, and please feel free to use this in the future. I will try to have more of these videos, if you guys like them, shared onto Canvas as soon as possible.